So we are going to solve for angular displacement. Angular displacement is in degrees or radians, and we want to measure in physics using radians when we're doing our equations. If we are given the angular displacement of 40 degrees, we need to convert that to radians, which is 40 times pi over 180. That will give us 0.7 radians. Okay, so let's say that we're given the initial position and final position. So the initial position is an angle of 30 degrees. The final position is an angle of 75 degrees. Like any equation with a delta, we're going to subtract the final minus the initial position, which will give us 45 degrees. Now we want that in radians, so we're going to multiply by pi over 180. This gives us 0.79 radians. Now, if we're given our Cartesian coordinates with a y value of 5 and an x value of 6 meters, and we know our hypotenuse, otherwise known as our radius for our circle, is 10 meters, we can solve our angle using SOHCAHTOA. I'm going to use sine, which is opposite over hypotenuse, which is our y over our r. So 5 divided by 10. And to solve for the angle, we'll have to move the sign over, so it'll be the sine inverse of 5 over 10, which gives us an angle of 30 degrees. Now we have to convert that to radians by multiplying by pi over 180. This gives us 0.5 radians. Last but not least, let's learn about arc length, which is the distance traveled along a circular path. It is on that curvature from your initial position to the final position. Now, in order to solve for this, we need to know the radius and we need to know the angular displacement. The equation to solve for arc length is radius times the angular displacement. So here's an equation to practice all that we've just learned. A bike wheel with a radius of 0.10 meters moves from 0 degrees to 30 degrees. What is the arc length? Our change in displacement will be 30 minus 0 degrees, which gives us 30 degrees. Now we got to convert that to radians, so multiply by pi over 180. So that's 0.52 radians. And our radius is 0.10 meters. So just plug these into the equation, which is 0.052 meters, which is the distance traveled along the circular path.